अब every element needs stable configuration configuration except noble gases except noble gases as they already have they already have like helium symbol is He, atomic number is 2, electronic configuration is also 2. Now we have neon Ne, atomic number 8. This is Z, atomic number I am writing. This is and they have 2,8. Sorry, its atomic number is 10. Atomic neon is having atomic number 10. Then we have argon, that is Ar. Its atomic number is 18. It is having 288. Fine, and so on. So they are having stable configuration. They have a stable configuration, so they do not undergo chemical reaction. So they have stable configuration, configuration. They have stable configuration, so do not undergo a chemical reaction, right? Chemical reaction. Other elements undergo chemical reaction to complete their octet or to get electronic configuration of nearby inert gas right? So the initial question which I asked to you, why elements undergo chemical reaction, so answer is this, right? Elements undergo chemical reaction to complete their octet, right? Octet, or to get electronic configuration of nearby inert gas, right? Hello. So what I said, this is the answer of my question which I asked you initially, that why elements undergo a chemical reaction. So the answer is other elements undergo chemical reaction to complete their octet or duplet or you can say duplet also. In case of hydrogen, they duplet or duplet, right? Duplet, or to get electronic configuration of nearby inert gas, right? Up this, so to they attain the stable configuration by two ways. They attain elements attain stable configuration by two ways, right? Two ways. What are those two ways? Can I rub this? Can I rub this? Should I? Elements attain stable configuration by two ways, right? First, should I rub? So, elements attain stable configuration by first exchange of electrons, but right, exchange of electrons means or by losing or gaining electrons, right? Electrons. By losing electron means, you know the sodium atom. Did you heard about sodium? I hope you heard, right? Sodium has 11 protons, 12 neutrons, and it is having 11. So since it is having 11 protons in the nucleus, so there are 11 electrons in different energy shells, right? So first it has 2, then in the another cell it is having 8, right? 1 2 3 4, 5 6 7 8, and after that it is having outermost shell, it is having 1 electron, right? This 1 electron this is the valence electron. This is valence electron, right? It loses this valence electron, and its electronic configuration is 281. Atomic number is 11, right? So it loses this electron and get the stable configuration of 28, right? Get the electronic configuration of 28 and get a stable configuration. Configuration, right? And in doing so, there are now it has 11 protons in the nucleus but 10 electrons in the orbit. So it gets plus 1 unit positive charge. It gets plus 1 unit positive charge and it becomes sodium ion. Sodium ion, right? Similarly, there is one more element you know I hope, that is known as chlorine, right? Cl. It is having 17 electrons, 17 protons, and it is having number of 17, 34. It is around uh, 18 neutrons it has, and in different energy shells, number of, in first it has 2 electrons, after that it has 8 electrons, right? It has 8 electrons, and after that in outermost shell, that is valence shell, it has 7 electrons, right? So that is 1, 2, 3, 4, 5, 6, 7. Its electronic configuration is 287, right? This is chlorine atom, this is sodium atom, this is sodium atom, and this is sodium ion, this is chlorine atom, right? It has 7 electrons in valence orbit. So what happens, it takes this electron, which sodium has lost, it takes this electron and become stable, right? It takes this electron and become stable, and its electronic configuration becomes 288. It is the electronic configuration, but you see here it is having 7 protons in the nucleus, and now it is having in outermost shell 18 unit of positive charge, so it gets 1 unit negative charge, right? So this is Cl, that is Cl1 minus, right? And this we called chloride ion, that is Cl1 minus, right? They both combine together, they both combine together and get a electroequivalent compound, that is Na plus Cl minus, right? This is electrovalent compound, and they get a stable compound, and they all get the stable configuration. It gets the stable configuration of 28 sodium, and chlorine gets 288. They both get the stable configuration, they become stable, and how they become stable? By exchange of electrons. Sodium loses electron, chlorine takes electron, and they both get their stable configuration. So this is the one way of getting stable configuration. This is exchange of electrons. Did you understand what I said here? I hope you understand. Hello? Are you sleeping with open eyes, man? This is sodium atom, right? So sodium atom, and should I rub this? This is one way to get the stable configuration by exchange of electrons, and another way, I'm going to rub this. Should I do? Hello? Can I rub this? Now another way to get the stable configuration is, Another way to get stable stable configuration configuration is by, you know, sharing of electrons. Did you understand? Sharing of electrons. Sharing of electrons. Right? Now, I hope you understand well. You heard about oxygen? Oxygen atom. Oh my God. This is oxygen. Oxygen is having atomic number, 8, and it is having 6 electrons in its outermost shell. Valence shell, it has 6 electrons, right? And you know very well hydrogen. Hydrogen is having atomic number 1, right? And that's why it is having first group and first period of the periodic table. It is having 1 electron, right? So by sharing of electron, hydrogen takes this electron of oxygen and get the stable configuration of helium and become stable, right? Similarly this hydrogen atom takes electron and becomes stable, right? And oxygen takes 1 electron of this hydrogen atom and takes one electron of this hydrogen atom and becomes stable. Now hydrogen is having 2 electrons in its outermost shell, and oxygen is also having 8 electrons in its outermost shell, and they both become stable, right? This is by sharing of electrons. This is by sharing of electrons. This is by sharing of electrons, and it is a molecule of water. It is a molecule of water. A molecule of water. Fine. A molecule of water, and these electrons which are taking part in a chemical reaction, electrons which are taking part in a chemical reaction, electrons which take part in bond formation called shared electron pair. Shared electron pair, right? These are shared electrons. So these are shared electrons which take part in bond formation called shared electron pair. So these are shared electron pairs, and these are those who do not take part in bond formation. They are known as lone pairs. Those who do not take part in bond formation known as lone pair. Fine. I hope you understand. Hello. Those who do not take part in bond formation known as lone pair, and those who are taking in bond formation, they are known as shared electron pair. And a chemical bond, a chemical bond, a chemical bond, a chemical bond formed by two electrons, two electrons in a chemical bond formed by two electrons which come from which come from which come from two different atoms, two different atoms, two different atoms in covalent compounds, in covalent compounds. Getting? Getting? So what I said, electrons elements undergo for chemical reaction to attain the stable configuration, and they get the stable configuration by two ways. One is by exchange of electrons and form electrovalent compounds, and here by sharing of electrons, and that is sharing of electrons, they form bond, and a bond formed by two electrons which comes from two different atoms, those electrons which take part in a bond formation are known as shared electron pair, and those who do not take part in bond formation are known as lone pair. Getting my point? So why reaction occur?